feel like that just adds so much to launching the rocket, just knowing what exactly happened, and you like can see it. I feel like it makes a huge difference, like you said.
Right. Like that's actually how we kind of determined this air brake theory in the first place. We had two cameras, one on each section, and uh, the camera on the aft body tube section was pointing upwards after deployment, and it saw that the air brakes were fully deployed, which was obviously a very big error. So we are able to catch that. If you guys want, I can recommend some cameras. I believe we use the what is it? The Run Cam. Uh, sorry, I'm looking this. Oh, the Run Cam 5 and the RunCam 2. They're like really small cameras. And what we literally do is we 3D print a mount on the outside and then we just drill in. So like right before like the rocket launches, we just turn it on, we put in the batteries, make sure everything is good. And then it's a pretty hardy piece of device. And even if it does crash or have slightly harder fall, it'll survive. Actually,
So
I know
you,
it'll survive.
so
Yeah.
y'all like slide it into the airframe?
No.
There's like a
So
slot for it.
no, it's actually poking out of the airframe. So, man, I wish I had like a demonstration piece or something. But if you imagine like um it's like a or it's like a 1/8 of a 1/4 of a sphere, and then you just kind of mold it so that the flat side is where the camera sits and it just records downwards. And then the curved edge is what actually goes into the wind. So it's still nominally aerodynamic. I don't know if I'm explaining this very well. I can find some pictures. I'm sure they're around there somewhere if you guys want further clarification.
Photos would be great, but you're definitely making sense. So,
I could put my MS Paint skills to use if we really need. But yeah,
Man, all professional engineers use Microsoft Paint. It's just a given.
yeah. No, I literally at work the other day, I was like, all right, I gotta explain how to do this, but they don't give me the fancy drawing thing, so I just booted up
Mm,
MS Paint because every computer has that. My
yep,
mentor wasn't very impressed, but he got the gist.
you gotta use what you have.
Yeah,
yep,
exactly.
yep. And the cameras don't give you any battery problems. I know we had one for our payload, but just in the heat, I don't think it lasted but an hour, and the battery just gave out on us.
Yeah, that is one of the issues that we do have, just how long it's out on the pad.
Mm,
And there's not really any way of getting around that other than have the camera being the last thing that you turn on before you head out to, or one of the last things that you turn on before you head out to pad. We usually do it roughly at the same time we put in ejection charges in. So, very, very final steps.
mm. Cool,
You
cool.
mentioned earlier that you had trouble with shoots. How many unsuccessful launches have you had with the ones that you made, and what caused that?
Let's see. In six. So the one this year failed, but it wasn't really any issue with the shoots. Any sort of shoot would tear at Mach zero point 0.7. Uh, but the one previous year, it failed. The drogue, I believe, deployed, but there was severe weathercocking. Like the wind was really bad, where we launched just up a bit north of Minneapolis. And because of that, we had more vertical or we had more horizontal velocity than we were expecting. And when the drogue deployed, it ripped it out a little bit, and that caused the main to also rip. And we got a streamer, so it still landed.
That's
I hesitate to say slowly, but it landed slower than if there was no shoot.
yeah, it's not a complete lawn dart, which is the end goal. So
Yep, there we go.
better than the alternative.
No core sampling. Oh man, there are some pretty stupid recovery failures too. One time, on one of our avionics bays, we we taped one of the wires in for our altimeter instead of soldering them in like an idiot, and no one else,
Mhm.
like one person worked on it. And to be fair, he was like this was like he was running on like 3 hours of sleep since he needed to get like this was done 2 a.m. right before the launch. But no one else really checked it. And the wires got jostled out on the launch, so the ejection charge never fired, and it lawn darted a good ways into the ground. We dug deep enough to hit water. So
Oh my
I don't
God.
know where the water line is in Minnesota, but we were out there for like 2 hours roughly digging.
For a minute, I thought this was spaceport, and I was like, "Y'all found water in the desert."
Yeah, no. This was somewhere up north.
Gotcha. So, how much of a heartache is it in terms of time when you do have your shoots go down like that and tear up?
Um, so the shoots that we made were specifically for recovery testing, so they were a lot smaller than the actual large scale, but it is still a pretty big pain to um recut. I don't know how much you guys know about the whole parachute creation process. I don't know. I know that there's a
Very
bunch
little.
of okay. There's a bunch of good resources out on um like cutting out designing like a gore. A gore is like one pedal of the parachute in case you didn't know. And there's like gore templates for ellipsoidal, which is probably what you want to make as the first one. It's nice, easy. It's like the half circle. Um, and then after doing that, you also have to sew everything in. Let me drop some links on you guys, if that's okay.
Great.
Much
I know you
obliged.
guys were talking about materials.
Yes.
So I found some old links. So what I just sent down is the materials that we use to actually make our parachutes. So we have ripstop nylon, which, as its name suggests, is nylon designed to rip less. I hesitate to say stop ripping because that's very much not true. But that's the actual base material. We also have what is called nylon tape, and that's like, well, it's the kind of tape-like structure, and we use that. We put two sheets of ripstop nylon on top of each other, and then we put the tape on top of those two, and then we sew through the tape. So the tape kind of adds an extra layer of strength, especially because wherever we're sewing, we're making lots of tiny holes, right? And that's more liable to rip. We used to use Kevlar tape and Kevlar thread. However, we changed over to completely nylon because someone did some research and they found that even though the nylon is weaker than Kevlar, you should try and sew similar materials together. So like nylon with nylon, Kevlar with Kevlar. So
Mm.
we think that would still be beneficial to downgrade to nylon. But we still have the suspension lines as Kevlar and the shock cord as Kevlar, just because those are the things that actually are by the um, thereby the ejection charges, and we want those to be fireproof. Also, nylon shot cord or nylon suspension line is just so much bigger and heavier than Kevlar ones. And trust me, you don't want to deal with that when you're already packing a chute that's mostly packed. It's like the entirety of what was allocated to you. Let me find the shot cords and I can post those down there.
Thank you. Yeah, I know anything to reduce weight, man. Weight is definitely a
Exactly.
big issue.
How did you guys do in the competition?
I'm gonna hand it over to Carlos.
I think, okay, honestly, I think our launch was pretty fucking good. But our drogue went off. Both of our charges went off. Our drogue went off pretty well, but then when it came to our main, we were using tender descenders, and we had one sec. Somebody's knocking on my door. I'll be back. Sorry.
I guess trying to pick up on that. So with our main, we had a bunch of I'm looking for the word, rubber bands wrapped around the shot cord on the main deployment bag. And of course, it's one of the things we did not give serious thought to testing beforehand, as far as them
Or
coming
wait,
off.
so rubber bands around like
So some of the flakes on the deployment bag. So we had the drogue parachute
right?
connected through the lines to the main bag. So when the tender descenders would go off, the force would pull the main out of its bag. We
Right.
had all of the the flakes just kind of taped on there just to reduce space and keep them all organized.
Mm-hmm.
But again, just something we didn't really give much thought to testing beforehand. So when everything actually did go to eject, drogue worked fine. However, one of the rubber bands did not come off the main bag, which
Okay.
just caused it not to deploy, and that was the story there.
Yeah, it's always the details that get you.
Always the
And
small things.
sorry, this is just going to be me going on a rant. Most annoyingly of all about recovery is that it's very hard to test. Like, with
Mm-hmm.
propulsion or structures, you can like kind of test it, but like as recovery, what you're gonna fly a big ass rocket up to like 1,000 feet every
Mm-hmm.
single time you want to test your chutes? At a certain point, it becomes exorbitant.
Yeah, and
Speaking from experience, we've crashed like so many.
Oh
it's like the
no.
only way to fully test is to like put it on a rocket, which is exorbitantly expensive, and then just
Right.
see what happens after. Like you were talking with the air brakes, only way to do it, put it on a rocket and go up.
Exactly. We, I mean, recovery, not this last school year, but 2 years ago, we were discussing if it was worth it to even test at all because one line of thought was that, hey, if it's gonna fail, it might as well fail at the competition because if we only have one shot at it, which I personally don't really like that reasoning, but I can kind of see the whole premise of it. Something that happened in previous years was that they tested out the main and drogue of the actual rocket like right before the launch, and I think it tore or something happened to it. And so they were sewing a new thing. So they literally brought sewing. Like we drove, I'm assuming you guys also drove to New Mexico. We drove down from Minnesota, so slightly longer drive. The people in recovery, at which it was only like 3 people, it was a very small sub team back then. They just grabbed sewing machines and we were sewing on the way down there.
Mm-hmm.
So,
Yeah. Can we tell you the story about our former nose cone?
oh, yeah.
So we were doing deployment testing. So our ejection bay for recovery is the
Mm-hmm.
area between I think it's the avionics bulkhead and the nose cone itself.
Right.
So We packed all the parachutes in there. We packed all the tender descenders, all the fun stuff. Launched it off. Lord and behold, it went much farther than we thought. And in hindsight, we probably should not have had pointed it towards a brick wall like we did.
Oh no.
And yeah, launched off, hit an electrical meter, and did not survive very long, sadly.
Ouch. Yeah.
It's like a month before spaceport, so that came as a sore blow.
Rest in pieces. What competition category were you guys?
30K
30K
cots.
Oh, okay, nice. Yeah. So, uh, you guys had more to do than we did. We only did 10K SRAD, but
Yeah, I heard y'all were supposed to do 30K, right?
well, we would have loved to do 30K SRAD, but Ezra didn't allow us to go to an O motor because that requires a level 3 standing waiver, and they just don't have that at Spaceport. So we had to, in order to still do our rocket, we had to downgrade to 10K to still be able to
Gotcha.
fly.
Well, hey, at least y'all still flew. That was pretty good.
Oh, sorry, a P motor, not an O motor. Yeah, but anyways,
Since y'all are SRAD, for recovery, y'all design your own chute. Do you use any other systems like CO2 ejection, mechanical separation, black powder?
we do not. So one thing I did want to look into was CO2. I was looking at the Raptor kit specifically. I don't know if you guys have used those before.
Yeah, we used the CD3 Raptor, isn't it?
Yeah.
Oh, really? Okay. I might need to.
We have the Raptor and the CD3, but this year we used the CD3, which I don't think we can use anymore. So we do have a Raptor, but nobody that's currently in the team has used it before, but we do have one.
Okay. So everyone has graduated who has used the Raptor kit.
Sorry, yeah, because we had it now for like 3 years maybe, and I think everybody who was in the team whenever they actually flew it graduated already. But at least the CD3, that one worked pretty well. That was our secondary this year, and it worked perfectly. And we did some ground tests with it, and it worked fine. And I don't think they sell the CD3 anymore. Now they sell the newer ones called like the Eagle or something. But I asked the alumni about the Raptor, and they said that it worked. It worked as expected. So I don't think they had any major issues with it.
Gotcha. Okay. If you guys ever do Raptor testing or any other CO2, would you let me know? Because I'm interested in
Absolutely.
yeah, I'd love to try a system like that for our high altitude rocket.
Yeah, because this year what we're wanting to do is we're wanting to have our CO2 system as our primary ejection system and then use black powder as backup. And then once we do that successfully, shift to just a fully CO2 system.
Gotcha. Okay, yeah, that's how many do you guys have, two altimeters or
Yeah, so our primary computer was the Telemetron V3, and then our redundant was the EC Mini V2 or something. I don't remember which one specifically. Joe, I think Joe might know that if she's here. I don't know.
okay. I'm not familiar with that. I bel or the University of Minnesota uses the Raven, Stratologger, and Telemetrum, I think. But I also don't do the avionics as much, so I foster that up to someone else who actually understands wiring.
Avionics is a different realm for us. We just know the flight computers and That's about it.
Right, for sure. Black magic as far as I'm concerned.
Exactly.
I had a question about y'all's testing for these parachutes. I'm guessing y'all build like really small scale parachutes first and then work your way up. But I was curious as to what consists of testing the parachutes, I guess.
Yeah, so are you guys familiar with the disc gap band design?
Oh no, not really.
No.
Okay, so I believe it was like pioneered by NASA for like Mars landing or something. I don't know why. We mostly use it because it's kind of fun to make, but it's basically like a also because it has some pretty good characteristics for high speed deployment. But it is basically a regular ellipsoidal parachute. And then there's like a small gap, and then there is a thin band that circles all the way around. If you like look up this gap band parachute, I'm sure you'll find like pictures. But yeah, so we use a variant of that, and this year and last year was the first time we've ever used a design like that. And we had the coefficient of drag data that was given in the NAC manual, but we had no way of verifying that. So what we tried was we made a design and flew it up, and then we calculated the descent speed, right? And you uh, after you know the descent speed, you can just back solve for coefficient of drag using all those aerospace equations that I don't have memorized. But through there, we were able to determine that our coefficient of drag was actually a lot lower than what we expected from the book. So we knew there was either some issue or like some certain way we designed it was different from what they expected. So that was kind of a good clue that, hey, this is going to slow down our rocket a lot less than we expected. So we decided to make our actual drogue just a little bit bigger than what we calculated.
Sounds pretty good. Um, how small did y'all start with these parachutes? Because I'm guessing it would take a lot of practice and skill to make like a 12 feet or 12-foot parachute. Those are pretty big.
Yeah. Let me. I actually have a video of one of our parachutes deploying, but I don't know where it is. I don't know. I'll look for it. But yeah, we definitely started out way smaller. I can't give you exact numbers since I don't know them off the top of my head, but I know we fit them in on a 4-inch rocket that went up to, I think it was like 600 feet or 500 feet, just enough to be able to get the wind underneath the parachute. And from there, we kind of moved upwards until we had something that was uh, I could deploy at like 1,000 feet and was slightly closer to the actual scale of our parachute because coefficient of drag doesn't scale linearly, but it's a good estimate as best as we're going to get it without actually just flying the parachute in the first place, which would kind of ruin the point of tests.
For the
Yeah.
parachute ripping, I know that, and granted, this would be a different concept, but would it be possible to apply it? So for solar sails, NASA and other aerospace companies, just because of how thin the material is and how prone it is to ripping, they use a certain type of stitch. Would it be possible to do that same thing within the parachute to try and mitigate any rips or failures?
That is something that I am not aware of. I know there are some stitches that are less prone to ripping than others. But I will profess that I have not done too much design in or too much research into the actual like style of stitching. I've always been meaning to, but I haven't really found any good resource. Honestly, if you find something, could you send that to me? I'd be really
For
interested
sure,
in
yeah. We'll
looking
send you
at it.
everything we find out on that front. Yeah.
Yeah.
I think that would be a really interesting thing to test, like having different stitches and seeing, or maybe coming up with a uh, test stand, or some way of just testing how much force would it take for it to fail. That would be pretty interesting.
Yeah, for sure. I would like to point out that at least from just experiments that we've done, uh, the actual point of failure oftentimes isn't quite the stitch itself, just because it's reinforced with that tape. It's like right next to it. So it still has most of the force applied, but it doesn't have the protection of the nylon tape. Could you let me share my screen? I found a video
Oh,
of our main from this last year, fully deployed
let me see.
on the parking lot. We were just testing to see if it would billow, but
Go for it. It should be working. If it's not, let me know.
it still says host disabled.
Now does it
Oh,
work?
okay. Yep, now it works. All right. Can you guys see this?
Yes.
Okay, so this is our main. As you can see, it's really big. Like, uh, but we did a run test in the parking lot of our hotel.
That's awesome.
Yeah, but that was like, 2 stories. Like when we barely had enough space in our hall in our like uh aerospace building hallway to lay out all of this. But it was, for the record, the design sucked. Like the annular design we picked, it was like a donut cut in half. It led to double the amount of shroud lines, which led to twice as many opportunities to tangle, and it did tangle. Um, but it looked cool when it was fully inflated, so that was something.
I mean, I'm sure with how much experience y'all learned from making that one, you can move your way up and make some more interesting parachutes. But I think that's really cool. Like it was a really big parachute, but man, that I'm excited to see if we can do something like that. Um, I was wondering what resources did y'all use to, I guess, learn how to stitch, learn how to cut the different gores and all that? Like what resources did y'all use basically for manufacturing and I guess learning everything?
Yeah, so our base book was the big NACA parachute design manual, like the 500-page one. And kind of from there, we developed preliminary sketches. And once we were kind of confident in the design we chose, we then moved on to, how the CD would actually work with the dry weight of our rocket and what size parachute that would need. For that, we there's a lot of resources online, like on rocketry forums from other people who send their own parachutes. We use that to kind of get started, and then what we ended up doing was using SolidWorks to create our Gore template in there, turning that into a DXF file, and then laser cutting it into just a plywood board, and then you could lay that out onto your like ripstop nylon, and you'd be able to make a whole bunch of traces of it, and that'd be relatively consistent.
All in all, how much does this usually cost y'all?
Um, Let me. Sorry, I'm looking for the budgets. I would say our sum total of the parachutes was around like $3,000 if we're taking into account other stuff like we use three altimeters. We have a few other like we had the whole bunch of cameras that I mentioned. We have a total spending of around 7,000 a year.
Okay, so not too bad. I mean,
Yeah,
sticker shock, but
relatively.
yeah, it
Yeah.
could be worse.
Is it possible to see like a technical report on y'all's recovery system?
Oh, yeah, sure. I can send you guys our final technical report. It should be in there somewhere. I don't know how much detail the recovery lead went into, so yeah, if there are any questions, feel free to ask.
Yeah, I just I guess I want to learn more, but um yeah, I'm looking at this and I feel like the start is always the most difficult, especially if you've never done it before, because you don't know where to even go. So I'm trying to get, I guess, everything out of you while we
Right,
have you. So thank you for helping us out.
for sure. I mean, I would love to keep in touch throughout the year. There's, not a lot of teams making their own parachutes, and if you do decide to do that, we can compare notes, see what does work, what doesn't work, all that stuff.
Absolutely, that would be great.
Yeah. And again, I apologize if I sounded overly negative at the beginning with all my naysaying, but I just wanted you guys to have a realistic expectation, not that it was all sunshine and daisies and it would all work out perfectly.
That's engineering for you.